Good day, good evening, and good morning. Welcome to another edition. In this session, we'll be looking at an introduction and overview of partial fractions. We'll focus on the concepts and do problems which will aid in our understanding of partial fractions. So as a point of departure, let's quickly look at polynomials. So polynomials usually take the form of, if we have a of x or alpha of x like this, our polynomials will always take the form of an x to the power of n plus an minus 1 x to the power of n minus 1 plus, and so on until we reach the last term, which is a0. And on a previous video, we did define that a1 or a0 as an example in this case will be what is a constant, and our an, what it will be the coefficient, it will be the coefficient of our x to the power of n. And what we previously had a look at was the idea of a degree. If you recall, we said for a polynomial, a degree is the highest power which we see on the polynomial. As an example, if we quickly have a look at the degree of this exponential or of this polynomial here, so let's have a look at the degree of x squared plus 2x plus 1. If you look at the highest power which we see on this polynomial, you will see that it is 2. So our degree will be 2 for this problem. And if we quickly consider another example where we're looking for the degree, and what we have is 3x to the power of 2 plus x to the power of 4 plus x plus 2, we will look at this polynomial and ask ourselves, what is the highest power which we see here? And if you look carefully, we see it where we have x to the power of 4, which means the degree of this polynomial here is simply equal to 4. This is relevant because when we do partial fractions, which is what we are getting into, all what we are doing is we are dividing polynomials. That is all what we are doing when we are doing partial fractions. You are dividing polynomials. So let's have a look at a general case of partial fractions. So let's consider having a function which is n of x, which is going to divide, as an example, another function which we'll call it m of x. So what you should note here is that n of x and our m of x are polynomials. And as you can see, depending on the degree of either n and m, we can classify the partial fractions as a proper fraction or improper fraction. So let's have a look at a proper fraction. So if we look at the division of n of x divided by m of x, this division will be considered proper. It will be considered a proper fraction if the degree of the numerator, which in this case is n of x, if that degree is less than the degree of the denominator, which in this case it is m of x. So very important. So we'll consider any partial fractions or two polynomials dividing as a proper fraction if the degree of the numerator, which is n of x in this case, is less than the degree of the denominator, which is m of x in this case. So let's go to the next page and look at an improper fraction. Now let's have a look at this case, which is the improper fraction case. So a fraction which is n of x divided by m of x, it is considered improper if the degree of the numerator, which in this case it is the degree of n of x, if that degree is greater or equal to the degree of the denominator, which is m of x, this would be considered as an improper fraction. So as we are going to be doing partial fractions, once you get an improper fraction, the first thing which you need to do is to do long division. So let's quickly make a note of that, which is that when you have an improper fraction, you need to do long division first before you can split it into its partial fractions. This note here is very important, which is that when you have an improper fraction, you must make sure that you do long division first before you even start doing your partial fractions. So what we are going to do is we are going to be looking at the general partial fractions form, which is what you should understand, and then we'll dive into examples and see how we solve specific problems. So here I'll just call this the general partial fraction approach. So what we are going to have is we are going to have the compact form. So let's go to a new page, and then we are going to have the splitted form. So what we are going to have is, as I say, it is the compact form, and we are going to have the splitted form. So we are going to be looking at several cases. So let's go ahead and do so. So if I have a partial fraction which is of the form px plus q, all divided by, and this is divided by x minus a multiplied by x minus b. This, when I split into its partial fraction form, it will be a divided by x minus a plus b divided by x minus the small letter b. So meaning whenever we have something which is looking like what we have on the compact form, when we split it, it will look like what we have on the right hand side when we split it into its partial fraction form. Let's have a look at number 2. So this will be number 1. Now let's go to number 2. So if in number 2 we are given px minus q as an example divided by x minus a all squared, and what is very important for you to note is that if you look at the degree of the numerator, it is 1. But if you look at the degree of the denominator, you'll have an x times x. So the degree of the denominator will be 2, which means what we have here is a proper fraction. So remember, we said for a proper fraction, the degree of the numerator, which is n of x, should be less than the degree of the denominator, which is m of x. So when you have such a case, what you should note is that since you have a square there and there's something in bracket, it means that you have repeated roots. And what you have when you have repeated roots is when you split it, you will have, in this case, it is 2. So what we are going to have is a divided by x minus a plus, since there are 2, it means we are going to split it twice. So we'll have b divided by The second one will have the square. So it will be x minus a all squared. So if it was a cubed, I was going to say plus c divided by x minus a cubed. So please make sure that you are aware of how to split it when we have repeated roots like that. Okay, now let's have a case where we have px squared plus qx plus r, and this is divided by x minus a, x minus b, and x minus c. So we are still happy. We do not need to really do long division, because if you look carefully, the degree of the denominator, when you multiply the x's, it will be 3, but the degree of the numerator is 2. So as long as the numerator is a degree which is less than that of the denominator, we're happy. If not, we're going to need to do long division first. So when we split this, on the other side, what you should be able to see is that we will have a divided by x minus a, then plus b divided by x minus b, capital letter B, plus c divided by x minus c. So all what we need to go and figure out is what is the a, the b, and the c, the ones which are on top. And we'll see how to find that a bit later. Okay, let's go to number 4. So in number 4, what we are given there is a form which is px squared plus qx plus r. And this is dividing x minus a all squared multiplied by x minus b. And if you look at what happens is we have a repeated root here. So we have a repeated root because there's a square on one bracket. So you remember how to deal with that. We did it previously. So it means for that square, I'm going to have a divided by, I have x minus a, and then I need to have another term which is b divided by, since there's a square, I need to have x minus a squared. If there was a cubed, I was going to put the square term, then go to the cubed term. Okay, so that is what we have when we have that portion splitted. And then the other portion, which is x minus b, this will just be added here as c divided by x minus b. What I need you to note is that the terms that always have a degree of 1, like this one, this bracket, at the top it always has a term which has a degree which is 1 less. So meaning a term which has a degree which is 0. And remember that a degree of 0, you only get it when you are dealing with a constant term. So that is why when you look at the x minus or the terms which have x minus something or plus something on the denominator at the top, you'll always see a constant. Because 1 degree less 1, you get a constant. So that is how we would split this one. So let's go to number 5. Maybe let me create some space here. And we wrap this up on this page. Let's have a look at number 5. And see what we get. So for number 5, we have an expression which is of this form. We have px squared plus qx plus r. And this is divided by, look carefully, what we have is x minus a multiplied by x squared plus bx plus c. And this, when we split it, we have a couple of things which we note. So assume that it is not easy to factorize this portion here. So let's say that x squared plus bx plus c can't be factorized. Then what we end up having when we split it, if that x squared plus bx plus c can't be factorized, we'll end up having a divided by x minus a. We always have a constant on top of a denominator which is degree 1. And then now, because we have this here, which can be factorized, bx plus c, whenever we are dealing with such expressions, at the top, you always put an exponent which is 1 degree less. So if you look at how we move from the numerator or from the denominator to the numerator, that is just 1 degree less. That is what happened. So in the denominator with a degree of 1, when you go up, that is a constant. So if we have a degree of 2 on the denominator for that part, when we go to the numerator, we must have degree 1. And degree 1 is an expression which is linear, bx plus c, like this. This is how we are going to deal with the different forms which we are presented with when we are doing partial fractions. But specifically, this one is for what you would call it when the fraction is already a proper fraction. So with that said, let's go and have a look at a couple of examples. Okay, so let's have a look at example 1. So for example 1, we are required to find the partial fractions of the function below. And the function which we are given is 1 over x squared minus 1. So here we do not need to do any division of any kind or long division, as I previously mentioned, because when you look at the numerator, you have 1 there. And by now you should know that the degree of 1, which is a constant, is 0. And when you look at our denominator, you'll see that you have a degree of x squared minus 1, which is going to be 2. And that is our denominator and numerator respectively. And remember that as long as the degree of the numerator is less than the degree of the denominator, we don't need to do long division. So we become happy when we see such. Okay, so now we can go ahead and do our splitting. So because we have a quadratic expression on the denominator, what we want to do is to split it into its respective linear factors. So that will be x minus 1 and x plus 1. And this is what we are going to use to be able to write down our partial fractions expression. Once the brackets, or once we have factorized into its linear factors. So what we're going to have is 1 over x minus 1 multiplied by x plus 1. And this will be equal to a divided by, remember that we have degree 1 on this. So that's why at the top it must be 1 less. And a degree of 0 means a constant. So we're going to have x minus 1 and then plus our b divided by x plus 1. So now the question becomes, how do we find a and also how do we find b? So there's a couple of ways, but the approach which I'm going to take is that we should multiply the right hand side and the left hand side with the common denominator. That is what we should do. So this here, I'm going to consider it as the left hand side, and that there, I'm going to consider it as the right hand side. So what we want to do is multiply the left hand side and right hand side with the common denominator. And in our case, if you look carefully, the common denominator will always be what is usually on the left, which is the compact form. So the common denominator for our problem will be x minus 1, x plus 1. So let's go to the next page and quickly multiply the right hand side and the left hand side with this common denominator, and we will see what we obtain. Okay, So if you look at what is going to happen now is the denominators will cancel. So x plus 1 and x plus 1 will cancel. X minus 1 and x minus 1 will cancel. And when you look at the left hand side, will be left with 1. While on the right hand side, if you look carefully, you'll have x minus 1 into x minus 1, x plus 1, and then plus b divided by x plus 1 multiplied by x minus 1, x plus 1. And if you look at what is going to happen is x minus 1 and x minus 1 will cancel for that, and x plus 1 and x plus 1 will cancel for that portion. So essentially what we are left with is a into x minus 1 plus b into x plus 1. And there's a couple of ways to deal with this. So remember, our question is still how do we find a and how do we find b? So we can do it in many ways, but what I'm going to do is I can see that if I set x is 1, this entire term will end up being 0. Then I'll be left with the b, put in 1 there and somehow be able to solve for b. So I'm going to substitute x is 1. When I put in x is 1, I get 1 equals a into 1 minus 1 plus b into 1 plus 1. And if you look carefully, this term here will end up being 0 because of the 1 minus 1. So we are left with, if you look carefully, 1 equals 2b. And when you divide, you should be able to see that our b will be 1 over 2. So we're done. We have our b. We can now go and figure out our a. So let's quickly put our b here. Our b is 1 over 2. So now we should ask ourselves, what about a? Well, for a, I can do something interesting. For a, if you look carefully, if we set x to be minus 1, this entire bracket becomes 0. But this one will not become 0. So I can set x is equal to minus 1. So let's go ahead and do x is negative 1, which means when you look at this expression here, which I'm going to call it the reference expression or the reference equation, it is going to be a into negative 1 minus 1 plus b into negative 1 plus 1. And if you look at where we have the b, all of that is going to amount to 0. And if you look at what we will have, we'll have 1 equals negative 2 times a. And if you solve for a, you should be able to see that our a will be negative 1 over 2. So this means we can now go back to our original equation, sub in the a and the b. So this means that our expression, which was given as 1 over x squared minus 1, is simply equal to, where there's the a, it's negative 1 over 2 divided by x minus 1 plus the b, we found as 1 over 2 divided by x plus 1. This is our expression splitted into its partial form. I hope this makes a lot of sense. Let's go to example number 2. For example number 2, we are required to find the partial fraction of the function below. And what we are given is x plus 3 divided by x squared minus x minus 2. So this makes us happy because we can see that the degree of the numerator is less than the degree of the denominator. So let's quickly have a look at what we are supposed to do now. Step number 1. What we are supposed to do on step number 1 is I always advise that you check the degree of the numerator versus the degree of the denominator. And the reason why you do this check is so that you know if you are required to do long division first before you even do your work. So if you look carefully, for this problem at least, we do not need to do any long division because you will come to an appreciation that the degree of our numerator is 1 and the degree of our denominator will be 2. Okay, so now let's go to our step number 2. So for step number 1, we just check the degree of the numerator and the denominator. If the degree of the numerator is less than that of the denominator, which it is 1 versus 2, we are happy because it means that this is a proper fraction, so no long division is needed. So we should go to our step number 2 now. And for step number 2, we are required to factorize the denominator. So if you look at our expression x plus 3 divided by x squared minus x minus 2, our denominator is what we need to factorize according to this step. So we need to figure out what are two numbers when you multiply them, you get negative 2, but when you add them, you get negative 1. If you think carefully, that will be a negative 2 and a positive 1. And once this is factorized like this, it means we are ready to go to step number 3, where we split our partial fraction according to what we learned somewhere back here. So now let's go to step number 3, where we need to split our fraction. So if you look at our fraction, on the denominator, we have two linear factors, x minus 2 and x plus 1. So what I'm going to do is I'm going to have a constant which is 1 degree less than 1 divided by x minus 2 plus b divided by x plus 1. Now the question is obviously what is a and also what is b. That brings us to our step number 4, where on step number 4 we are supposed to multiply by the common denominator. So if you look carefully, on the left hand side, after multiplying with our common denominator, there will be terms which are cancelling. So the x minus 2 and the x minus 2 will cancel. The x plus 1 and the x plus 1 will cancel. So if you look carefully, what we'll be left with is x plus 3 equals 2. Now, when we look at the other terms, which are multiplying on the right hand side, you will see that this x plus 2 will cancel with that x plus 2 and then be left with x plus 1 multiplying a. So it will be a multiplied by x plus 1 on the right hand side. And when you look at for the other term, when we now multiply the b part, this x plus 1 and the x plus 1 there will cancel, and then you will have a multiplication by x minus 2. So the b will be multiplied by x minus 2. Now we need to quickly solve for what is a and also for what is b. So what I'm going to start by looking at, how do we solve for a? So the approach I'm going to take usually is, how can I eliminate the b here? And if you think carefully, how we can eliminate the b there is by simply making our x to be equal to 2. So because remember, we're looking for a now. So how I can eliminate that b is, if I make x to be 2, I'll have 2 minus 2 there. So now all what I do is I'll substitute wherever I see x, put in 2. So this will be 2 plus 3 equals a into 2 plus 3, 2 plus 1, then plus b into 2 minus 2. And that b term will be multiplied by 0. So everything goes away. And if you look carefully, we'll end up having 5. If you look at this, it will end up being 5 equals 3a. And if you quickly solve, you will see that our a will be given by 5 divided by 3. That is our value of a. Now let's go ahead and look for b. So for b, I'll take the very same equation and now figure out how to eliminate the other terms such that there is only b left. So if you think carefully, the term which I do not want is this term here. But how can I, null it down? If you look carefully, I can put x is minus 1. Because once I make x is minus 1, the entire term will be 0. Because I'll have negative 1 plus 1. So what we are going to do is put in x is minus 1. So I'll have minus 1 plus 3 equals a into minus 1 plus 1, which will give me 0, plus b into, if you look carefully, it will be minus 1 minus 2. So what makes me happy is this term here, which will become 0. So what I'm left with is a 2. If you look at this, what I'm left with is 2 equals 2, negative 3b. So I can easily solve for b now. Our b will simply be negative 2 divided by 3. That is what the b is equal to. So now that we have the b, we can just sub back to the original equation and finalize our answer. So if you look at what we were originally given, we're given that x plus 3 divided by x squared minus x minus 2. This will now be equal to, now if you look at where there was a, we are going to put what we found for a, which was 5 over 3 divided by x minus 2. And then for b, we have plus, if you look carefully, negative 2 divided by 3. And this is all divided by x plus 1. This is our functions after, or this is our function after splitting it using partial fractions. So let's go and have a look at example number 3. Okay, let's have a look at example 3. For example 3, we're given 5x minus 6 divided by x squared minus 3x. And we're required to split this into its partial fractions. And you would go typically through the steps which I do, which is checking the degree of the numerator and the denominator. In this case, they will definitely check out. So what I'm going to do is I'm going to go now and split the denominator into its linear fractions. So if you look carefully, what we should have is 5x minus 6 all divided by x squared minus 3x. So I need to figure out how can I factorize this denominator here. And if you look carefully, the denominator, I can pull out an x and be left with x minus 3 like this. And this I can write as, because we always prefer having x minus or x plus something. So I can write this as x minus 0 multiplied by x minus 3. And this is exactly the same expression which we have as the original one. Now, since we have that, we can now go ahead and split this into its partial fractions. So we have x minus 0 into bracket x minus 3. This will just be equal to a divided by x minus 0 plus b divided by x minus 3. And remember that what we do is we then multiply by the common denominator. So here what we were doing was to split this into its respective partial fractions. The next step is to just now multiply by the common denominator. So we'll take the right hand side, multiply it by the common denominator, and what we do on the left, we do on the right. So let's quickly take that and go ahead and multiply it by the common denominator, which is what we usually have on the left hand side. So our common denominator will be, it will be x minus 0, x minus 3. That is our common denominator. And what you do on the left, you also do on the right. So let's go ahead on our right hand side, multiply by the common denominator. So if you look carefully on the left hand side, there's going to be terms which will cancel. So the x minus 0 and the x minus 0 will cancel, and x minus 3 and x minus 3 will cancel, which means we are left with 5x minus 6 equals. So if you look carefully, this side, when we multiply the a term, the x minus 0 and the x minus 0 will cancel. So the a will only be multiplying with the x minus 3 plus b into. So if you look at the other term now, the b term, the x minus 3 will cancel the x minus 3, which means the b will simply be multiplied by x minus 0 like that. Okay, so this can easily be simplified to 5x minus 6, a into x minus 3, plus just bx, because x minus 0 is just 0, is x, sorry. So now let's go ahead and figure out what is a. And if you look carefully, since I'm looking for a, what I ideally do not want to see is b, because I'm looking for a. So I do not want to be disturbed by b. So if you look carefully, the easiest thing I can do is if I set x to be 0, the b will be multiplied by 0 and in turn disappear. So let's set x to be 0, and wherever we see x, we put in 0. So this will be a into 0 minus 3 plus b multiplied by 0. And if you look carefully, that term becomes 0 as we need it to be, so that we only have a which we need to deal with. And if you look carefully, we are left with negative 6 equals negative 3a. And if you quickly solve for a by dividing both sides by negative 3, you will see that our a is positive 2. Now let's go ahead and figure out what is b. We'll take the same expression which we had and quickly try and eliminate a in simple cases like this. So since we're looking for b, I should be asking myself, how can I eliminate or make the term to be 0 so that I eliminate the a? But already the a I have, but I can just choose x is 3. So what we are going to do is we are going to replace x by 3, which means we have 5 by 3 minus 6 equals a into 3 minus 3, and then plus b multiplied by 3. And if you look carefully, this here becomes 0, which means all what I'm left with is 5 times 3, which is 16. Sorry, it's 15. Then minus 6, that will give us a 9. So I have 9 is equal to 3b. And if you look carefully, when you divide both sides, you should see that your b is equal to 3. So we can now subtract. We have our a and we also have our b. So what this means is that whatever which we were given, which was 5x minus 6, divided by the original one, which was x squared minus 3x. When we split this into partial fractions, we had a divided by x minus 0, and our a we found is 2. So this will be 2 over x. I don't need to write the minus 0 because, 0 is 0. And then plus b divided by x minus 3. So the b we found is 3. Like this. This is how you would tackle example number 3. So let's go to example number 4 and see how we deal with it. Okay, so let's have a look at example 4. For example 4, we're given x plus 3 divided by x minus 2 multiplied by x plus 4. So what you should be able to see is that what we have here is linear factors, just as you know in a linear equation. So linear factors always have a constant on top of them when we break down the fraction into its partial fractions. So this means that we have x plus 3 divided by x minus 2, x plus 4. So what is very important is that the degree of the numerator is 1 and the degree of the denominator is 2. So it means there's no need for us to do any long division. So all what we need to say is a over x minus 2 plus b divided by x plus 4. Then what comes afterwards is just us multiplying by the common denominator. Okay, so when you multiply by the common denominator, you'll see that x minus 2 and x minus 2 will cancel. And remember, what you do on the left, you also do on the right. The x plus 4 will cancel. So on our left-hand side, what is left is x plus 3. And this will be equal to, when you multiply the other side, let's focus on what is below a. It will cancel with that, which means our a will be left to multiply with x plus 4. Then plus the b. If you look at the b, it is divided by x plus 4, which means it will cancel with that x plus 4. Then what will be left to multiply the b will be x minus 2. Then now we can go ahead and start figuring out how do we find the a. And the methodology for linear factors is as good as the same. Very easy. So what we are going to do is figure out how to make the other terms to be 0. So we're looking for a. If you look carefully, how can we make that to be 0? And we can just set x is 2 and that will be 0. So that's what we are going to do. So we are going to replace x with 2, which means we'll have 2 plus 3. If you look at the left hand side, a into 2 plus 4 plus b into 2 minus 2. And if you look carefully, the b will multiply with the 0 and be 0. And that makes us happy, because now all what is left is we have 5 equals 6a. And if you solve for a, you will see that it will be 5 over 6. So we're done finding our a. Let's go ahead and figure out what is the b. So let's copy the expression and go figure out b. So for linear factors, you should be getting the hang now. It should be very easy. So we're going to ask ourselves if we want b to remain, but the a part here we don't want. So I can set x equals minus 4, if you look carefully. So let's go ahead and do that. So it will be minus 4 plus 3 equals a into negative 4 plus 4. And this will be plus b into negative 4 minus 2, like that. And if you look carefully, this will add up to 0 and multiply to 0. So what we have left is essentially negative 1 equals minus 6b. And if you quickly solve for b, you should be able to see that b is 1 over 6. So we now have the a and we also have the b. It means we can go back to the original expression and write it now after it has been splitted using partial fractions. So that was x minus 2 into x plus 4. And this will be equal to, so we had a, and for our a we found 5 over 6. So it's 5 over 6 divided by x minus 2 plus, for our b we found 1 over 6. And that is divided by x plus 4. So you can write this in a way which, it depends on how you view it, but others would prefer writing this as 5 over 6 multiplied by 1 over x minus 2 as an example, and then plus 1 over 6 multiplied by 1 over x plus 4, and someone else would just pull out the 1 over 6 because there's a common factor of 1 over 6, and you'd be left with 5 divided by x minus 2 plus 1 divided by x plus 4. So there's many ways you can, write your final answer, but either way, as long as it is the same answer, you should get it correct. Okay, that is our example number 4. Now let's go to example number 5. Okay, let's have a look at example 5. So if you look at example 5, what you should be able to see is two things, which is that here we have a linear factor, and on the purple side we have a quadratic factor which we can't factorize further than this. So let's go ahead and deal with this. So what I want you to remember is that when we have a quadratic factor, on top of it, we always put a linear factor. So now what we are going to do is split the function into its partial fractions. So let's have a look at the linear function. So on the linear factor. So remember the linear factors, they always have a constant at the top, x minus 1. This is because the degree is 1. So on the numerator, the degree is 0. On the denominator, the degree is 1. So we always go minus 1 when we go to the denominator. So now plus, if you think carefully, if our denominator now has degree 2, and we want to quickly find what should be sitting on the numerator, remember I said it's minus 1 of the degree of what is on the denominator. So what we have is we have 2, and then we minus 1, which means we need to have degree 1. And an expression of degree 1 is very easy. It is simply bx plus c, and that is an expression of degree 1. So remember the denominator, at least when you have a single quadratic factor, should always be 1 more the degree of the numerator. Or you can say the numerator should have 1 less the degree of the denominator. It works either way, right? So once you're done doing that, what we need to do is to multiply by the common denominator, as we always do. So let's quickly do some multiplication here. So what you will see is that x minus 1 and x minus 1 will cancel on the left hand side. And x squared plus x squared, or x squared plus 1, will cancel with x squared plus 1. So which means we'll only be left with x squared minus 3. And this will be equal to, on the right hand side, we'll have a multiplied by. So the x minus 1 will cancel with that x minus 1, which means the a will be left to multiply with x squared plus 1. And then plus, if you look carefully, we have bc or bx plus c. And if you look carefully, this term here, when it multiplies with the other one, let's put a plus, sorry. This term will cancel with that term, which means this bx plus c will be left to multiply with x minus 1, like that. So now we need to go ahead and solve for a, b, and c. The approach for this one will be slightly different. So if I'm looking for a, I should realize that, okay, for me to find a, I can, do what we were doing, because a is on top of the linear factor. So we can try and make the other terms to be 0. So if I'm looking for a, if you can look carefully, I can easily say, what if I make x to be equal to 1? When I make x equals 1, everything which is not a, which is not related to a, will be 0. So let's put x is 1. So you'll have 1 squared minus 3 equals a into 1 squared plus 1 plus b into 1 plus c multiplied by 1 minus 1. Let's make some space. 1 minus 1, like that. So if you look carefully, that entire bracket that has the b and the c, because of this portion here, which will be 0, everything will multiply by 0. So if you look carefully, all what you find yourself having now is minus 2 equals 2a, like that. And you can easily solve for a, and our a will be negative 1. Okay, so now let's go and look for the b and also go and look for the c. So let's go and solve for c on the next page. Let's choose as an example c. So let's copy that expression which we had. And then because the a we already have, I'm just going to put it up here. So we found as -1, like that. So if you look at how I can find the c, because we have substituted a, so here what we did was just sub a is -1. So if you look carefully, all what I do not have now is the b and the c. But how can I eliminate the b? So if I look carefully, I can eliminate the b by setting x to be 0. Then the b term will disappear and the c will be left. So I can just go ahead and put in x is 0. So I'll have 0 squared minus 3 equals -1, 0 squared plus 1, and then plus b multiplied by 0 plus c multiplied by 0 minus 1. So if you look carefully, we'll end up having -3 equals -1. And then plus, if you look carefully, it will be c multiplied by -1. So this equation will end up being -3 equals -1, c. So when we transpose, you will see that we'll end up having -2 equals -c. And when you solve, you will see that your c is equal to +2. Okay. Now that we have our c, we should ask ourselves, what about our b then? So we now take the equation which has now the a, the b, or it now has the a and the c. So our equation is now x squared minus 3 equals -1 into x squared plus 1 plus bx, the c, which has found out that it is 2, then multiplied by x minus 1. So what we did is we sub the c. So which means the only thing which I do not know now is b, sorry. So for me to find b, I can actually substitute any x value as long as the b is not going to be cancelled, if you think of it. So what I'm going to do is, because I need to make sure that the b remains, I'm going to choose, let's say, x is 2. Because I know that 2 will not make this to be 0 and in turn make the b to be 0. So let's choose x is 2. So which means I'm going to have 2 squared. You can choose any number as long as it's not going to either make that to be 0 or collapse the bracket. So if I choose x is 2, you will see that I will have 2 squared minus 3 equals -1, 2 squared plus 1, and then plus b multiplied by 2, and then plus 2, and then multiplied by 2 minus 1, like that. And if you look carefully, we have 4 minus 3, which will just be 1. And what is inside here is going to be 5 multiplied by the negative. It becomes -5. And if you look at what is inside here, you will have 2b, like that. Let's make some space here. So you'll have 2b plus 2, like that. And if you look carefully, you'll have 1 equal -3 plus 2b. Then we just transpose to the other side. What we will have is 4 equals 2b. And when you solve for b, you should be able to see that our b will be equal to 2. So we now have a b value of 2. We can now go back and sub in and see what we find is our final answer. So therefore, what we were given, which was x squared minus 3 divided by x minus 1, x squared plus 1 will simply be equal to the a we found as -1, so it will be -1 divided by x minus 1 plus, we found our b, which is 2, so it will be 2x plus our c we found also as 2, so it will be plus 2 divided by x squared plus 1. This is our answer splitted into its partial fraction form. I hope you understand. Let's go to example number 6. Okay, so let's have a look at example 6. Example 6, we are required to find the partial fraction of the function x minus 1 divided by x plus 1 multiplied by x minus 2 squared. Two things which I want you to be able to notice here, which is what we have here, we have a linear factor. And what you should realize on the purple one is that what we have there is a repeated linear factor. Why is it repeated? It's because there's two of them because of that squared. And what I want you to remember is what we noted at the beginning of the session, which is form 2, which is that if we have repeated factors, as an example, if the factor x minus a is repeated twice, for that portion we are going to have a representation which is like this. So I need you to remember from earlier. So when we began the session, we noted these cases. So now let's go ahead and deal with our problem and split it into our respective partial fractions. So for the linear function or linear factor, which is x plus 1, all what it's going to be is just going to be a divided by x plus 1. Then for the other portion, which is a repeated linear factor, I'm going to have b divided by x minus 2, but plus c divided by, because it is a square, I need to include the other term squared. If it was a cubed, I was going to say plus d divided by x minus 2 cubed. So we increase 1 by 1 until we get to the highest power. In this case, it was just a 2. Then now we need to go and solve this. And remember that once you write your fraction into its partial forms, all what you do afterwards is you just multiply by the common denominator. Okay, so let's multiply by the common denominator. So if you multiply by the common denominator, you should be able to see that it's x minus 1. No, it's x plus 1. So x plus, that is a plus. So I'm not sure why that got removed. But x plus 1 and x plus 1 will cancel. And also x minus 2 all squared and x minus 2 all squared will cancel. So our left-hand side will be left as x minus 1 equals, our right-hand side, if you look carefully, will have a into the x plus 1 will cancel. So the a will be multiplied by x minus 2 all squared plus b into. So for the b, x minus 2 will be cancelled, but there's two of them. So it means that one of the x minus 2 will be left, but also the x plus 1 will be there. Okay. And then plus, when we look at our c, you will see that it has a denominator of x minus 2 all squared, which means it will cancel with the x minus 2 all squared, and we will only be left with x plus 1 multiplying it. Okay. And then now, the simplest way to approach this is always get the factor of the linear component first. It is always the easiest. So if you look carefully, we can start by saying, what is a here? And for a, we just need to have a look at how we can make all the others to be 0. All the other variables, or constants rather. So if you look carefully, if I set x is negative 1, that will be 0, and that will be 0. So if we just set x is minus 1 it will take out the b and also the c. So let's go ahead and do exactly that on this page here. So we'll set x is -1 because we just want to be left with the a. And if we do so, on the left hand side we'll have -1 minus 1 equals a into -1 minus 2 all squared, plus b into -1, -2, -1 plus 1, then plus c into -1 plus 1. So if you look carefully, there's nice cancellation of terms. This entire term becomes 0, and also the other one, this here, the c will be multiplied by 0. So which means all what we have is simply -2 equals -1 minus 2 and then all squared. That will give us 9. So this will be 9a. And if you quickly solve for a, you should be able to see that our a will be -2 divided by 9. That is what our a is. Okay. Now we need to go ahead and figure out what is b or what is c. So if you think carefully, now that we have a, the next thing which is easy to find is actually c. Why is it easy to find? It's because you can eliminate b by setting x is 2, and also that will also eliminate a. So we can easily find the c. So let's go ahead and have a look at what is c. So I'll take the equation, and then where there was a, I'm going to replace it with whatever which it is. Copy that. So we're looking for c now. So this is equal to x minus 1. So if you look at the a, we found as -2/9. That is what it is. But if I look carefully, because I'm looking for c, and I don't want the c term to be 0, it means my x can't be -1. But if I look now at the b, I can set x is 2. But lucky enough, the x is 2 is going to eliminate even that term. So let's go ahead and deal with x is equal to 2. So what I'll have is 2 minus 1 equals -2/9 into 2 minus 2 all squared plus b into 2 minus 2, 2 plus 1, and plus c, which is 2 plus 1. And there's terms which are going to nicely cancel. So that there is all going to amount to a 0 because of 2 minus 2. And this also will also amount to 0. So if you look at what is left, 2 minus 1 is 1 equals 2. 2 plus 1, that will be 3. So we have 3c like this. So if you look carefully, we have successfully found our value of c, which will be 1 divided by 3. That is c. Okay. So now we need to figure out what is b, which is the last one. How do we find b? So what we are going to take is we will take the most updated equation, put in the c and the d, put in the a and the c, and then quickly figure out what is b. So not that. So for the c, we found 1/3. Like that. So for me to find the b, I just need to set x to be any number as long as it will not cancel out the bracket that has the b. So I can just choose even a very easy value, choose x is 0 as an example. So I'll have 0 minus 1 equals -2/9 into 0 minus 2 all squared plus b into 0 minus 2 multiplied by 0 plus 1. then plus 1 over 3 into 0 plus 1. So if you look carefully, we'll have negative 1 equals, when we square the negative 2, it will give us a 4. The 4 will multiply on top. We'll end up having negative 8 over 9. And then if you look carefully, the b will multiply with the negative 2, which will be negative 2b. And then plus, if you look carefully, 1 over 3. This can be simplified to be negative 1 equals, combine the like terms here. So 1 over 3 plus, 8 over 9. So that is the same as having 3 over 9 and then plus negative 8 over that. So this will just be negative 5 over 9 minus 2b. So let's go to the next page and quickly solve for b. Then we can finalize our answer and conclude our problem. So if you look carefully, we can transpose to the other side so that we have negative 1 plus 5 over 9. So remember that negative 1 can just be written as negative 9 over 9, and then this is negative 2b. So if you look carefully, what you will end up getting here will be negative 4. So it will be negative 4 over 9 equal minus 2b. Then when you divide, you will see that your b will simply be positive 2 over 9. That is what our b will be equal to. So now that we have our b, we can go back to the original equation and plug back the a, the b, and the c. Right, so we can go back and plug them in. So copy that and paste it here. So on the previous page, I found that our a is equal to that. So I'll just bring it the side. So that is our a. And our b, we found is that. And where is our c? C is 1 over 3. There it is. So now I can just go and plug them in. So if you look carefully, we have a, which means I should have negative 2 over 9. And this is divided by x plus 1. And then plus our b is 2 over 9. And this will divide x minus 2 plus our c is 1 over 3. And this will divide x minus 2 all squared. So if you see any mistake, please feel free to rectify it. This brings us to the end of example number 6. So let's go to example number 7. Let's have a look at example number 7. So for example number 7, we are required to find the partial fractions of the function below, which is x cubed plus 3x plus 1 divided by x squared minus x minus 2. So two important things which you need to realize here, which is that the degree of what we have on the numerator, which is x cubed plus 3x plus 1, is equal to 3. While the degree of the denominator, which is x squared minus x minus 2, that is equal to 2. And if you remember, we mentioned previously that if the degree of the numerator, if it is greater or equal to the degree of the denominator, what you have there is what we call an improper fraction. And at the beginning of this video, I made a note that once we have an improper fraction, there's something which is very important which we need to do. We first need to do long division. That is what we need to do. When we have an improper fraction, which means the degree of the numerator is bigger than the degree of the denominator, the first thing we need to do is to do long division, because what we have is an improper fraction. So let's go ahead and do our long division. So what we are going to have is x squared, or let's quickly maybe note that as step number 1. So what we need to do is long division. And it's because this is an improper fraction. The degree on the numerator is bigger than that of the denominator. So let's quickly do our long division. So what we have is x squared minus x minus 2. And this will be dividing x cubed. And this will be plus 3x minus what? Plus 1. Okay, so let's go ahead with the division. So we are first going to take x cubed and divide there. And if we have x cubed over x squared, what you get is x. Then you take the x, you multiply by it there. And what you will get will be minus, you'll have x cubed minus x squared, and then minus 2 like that. Then we take the difference. So if you look carefully, the x cubed and the x cubed will cancel. Then what you will be left is, you'll be left with x squared, and then the 3x will come down, and then you'll have a, look carefully, minus 2, that will be plus, adding with the 1 on top, that will be plus 3 like that. Okay, then what we can do now is to go ahead and divide one more, the x squared, with that. So x squared divided by x squared, that gives us a 1. Then we now need to take the 1 and multiply by it there. And that will be minus, when you multiply with the 1, you get x squared minus x minus 2. So let's quickly take this to the next page and see what we obtain. So please revise long division. There's a session that was focused on polynomials where we did long division. I urge you to check it out. So if you look carefully, x squared and x squared will cancel, and then we'll have negative x, or negative x, that will be positive. So we'll have 4x. Then if you look carefully, negative 2, that will simply be positive 2, which will add up with the 3 to give us a 5. Okay. So essentially what we have found here is our answer. So this here becomes our remainder. That there is our remainder. And what we have on top there is what we found when we were dividing. Then the remainder is what is there. So essentially our x cubed. So essentially x cubed plus 3x plus 1 divided by x squared minus x minus 2. The answer becomes what is at the top there, x plus 1 plus, now the remainder, 4x plus 5, and this will be divided by x squared minus x minus 2. So now what we need to find the partial fractions of is what is there on the right hand side. So we've done the work, but we need to further split this. This is where we need to split into its partial fraction. So split into partial fractions. That is what we need to do now. So let's go to the next page and deal with that problem and see what we obtained. Then we'll come back and plug it. So I'll take it as a separate problem now, and we will see how we work it out. Paste. Because the other part there doesn't need work, the x plus 1. It's solid and standard. So if you look at this, the denominator we can split into linear fractions. So if you look carefully, we have 4x plus 5. Our denominator can be written as x minus 2, x plus 1. So if we take this down here, because now our denominator is now linear factors, we now know how to deal with this. This will simply be a divided by x minus 2 plus b divided by x plus 1. So what we'll do, as we always do, you multiply by the common, what you would call it, denominator. So we'll now be multiplying by the common denominator. So if you look carefully, we do it on the left and on the right. So x minus 2 and x minus 2 will cancel. Then x plus 1 and x plus 1 will cancel. So which means on the right hand side, we are left with 4x plus 5. And on the left hand side, what you should easily be able to see is that the x minus 2 will cancel the x minus 2, which means the a will be multiplied with x. It will be multiplied by x plus 1. And then when you look at the second part of b, the x plus 1 and the x plus 1 will cancel, which means the b will be multiplied by x minus 2. So we can go ahead now and figure out what is a equal to. And that is easy. We have done this a couple of times. You should be finding it very easy for you to figure out what a is. So if I'm looking for a, it means I want to make one of or the other bracket to be 0. And the only way I can do so is by making x to be 2. So that is what we are going to do. So let's make x to be 2 so that we can solve for a. So this will be 4 times 2 plus 5 equals a into 2 plus 1 plus b into 2 minus 2. And if you look carefully, the 2 minus 2 there ends up multiplying the b, and it is 0. So that term collapses, and all what we have is 4 times 2, which is 8, plus what, 15, which is going to be 13. And this will be equal to a times 3, which is just going to be 3a. So if you look carefully, we have now found our a, and our a will simply be 13 divided by 3. Okay, that's our a, done and dusted. Let's go and figure out what is our b. And for our b, we take the very same expression which we have. And because these are linear, we don't need to substitute a. You can if you want. And what we want is b now. So we need to look and say, how can I make that term to be 0? Well, it's easy. Just put x is negative 1. So this means I'm going to be working with x is negative 1 to find the b. So this will be 4 into minus 1 plus 5 equals a into negative 1 plus 1, and then plus b into negative 1 minus 2. And if you look carefully, this term here will end up amounting to 0. And what you should be able to see is that you will have a 1 equals minus 3b. And when you go to the next page, you should be able to easily determine b. So our b will simply be negative 1 divided by 3. That is what b is. So we now have a and b. We can go ahead and plug them back. So we have 4x plus 5 divided by x squared minus x minus 2. This will be equal to our a we found as 13 over 3. And this is x minus 2. And then our b is plus negative 1 over 3, all divided by x plus 1. But remember that the original question which we were solving, I'm going to copy now, was that. So we just need to plug back to the main answer now to finalize this problem. So remember, we're dividing those. We first did long division. Now what we have is this portion. We now have found it there. So this means that our answer of what we're given x cubed plus 3x plus 1 all divided by x squared minus x minus 2. The answer is simply x plus 1 plus 13 over 3 divided by x minus 2 plus negative 1 over 3 divided by x plus 1. This is the answer which they are expecting from us of such a question. What is very important, which you should take away from here, is that once we have improper fractions, which is where the degree of the numerator is bigger than or equal to that of the denominator, you should make sure that you do long division first. Okay, so let's go to example number 8 and see what we get. Okay, so let's have a look at example 8. For example 8, we are given 2x cubed divided by x squared minus 1. So what you should be able to see right away is that this is an improper fraction. Why is it an improper fraction? You should be able to see that it is because the degree of the numerator, if you look carefully, the degree of the numerator, or the degree of 2x cubed, that is going to give us 3. And this here is our numerator. And when you look at our denominator, its degree, the degree of x squared minus 1 is 2. And this is our denominator. And as you can see, you can easily tell that the degree of the numerator is greater than that of the denominator. That is what makes it to be an improper fraction, denominator. Yes. And once we have this case here of an improper fraction, you should remember that we need to do long division. So because of this, we get an improper fraction. And guess what? We first need to do long division. So first, do long division. That is what we need to do when we have improper fractions. So let's go ahead and do our long division here. So let's start with our long division. Very important. So our long division, what we are dividing is 2x cubed. And it is divided by that there, which is x squared minus 1. So let's go ahead and do the division. So 2x cubed divided by x squared, that will give us 2x. Then you take the 2x, you multiply by it there. Then what you will have is minus 2x cubed minus 2x, like that. And when you subtract, you should be able to see that when you subtract the 2x squared and the 2x cubed and the 2x cubed will cancel, and our answer will just be 2x. And this can't divide further because the degree is 1 here and that one is 2 there. So this means that this here becomes our remainder. That becomes our remainder, the 2x. So it means when we divide these two, 2x cubed divided by x squared, we get 2x plus a remainder of 2x. So what does this mean? It means that 2x cubed divided by x squared minus 1, the answer becomes 2x plus we have a remainder of 2x. So that will be 2x divided by x squared minus 1. That is how you represent the remainder. It should always be on top of the original fraction. And then what leaves or what stays separate like this is what is usually there at the top. Okay, so which means now that we need to do, or this was a partial fractions problem, we need to do, or we need to deal with the second part, which is what we need to break using partial fractions. This part here is our worry. We need to separate using partial fractions. So let's go ahead and deal with that part. So if you look carefully, we have 2x divided by x squared minus 1, of which this we can easily write as, we can just split the denominator into linear factors. It will be x minus 1 and x plus 1. And for the longest of time, this we have known that as long as the degree of the numerator is less than the one of the denominator, this will just be a divided by x minus 1 plus b divided by x plus 1. And we can now go ahead and multiply by the common denominator in order to find a and b. So we'll multiply by the common denominator. The multiplication, you have done it several times, but when you multiply, you will see that you will get 2x will be equal to a multiplied by x plus 1 plus b into x minus 1. And if we're looking for a, it should be easy for you to see that all what we need to do is set x equal 1. And when we set x equals 1, the b term will cancel. So we'll have 2 times 1 equals a into 1 plus 1 plus b into 1 minus 1, of which that component there just becomes 0. And if you look carefully, you will see that you'll end up having 2 is equal to 2a, which means we have our a. Our a will be equal to 1. Now let's go for our b. So if we're looking for our b, you should by now, from the many problems we did, see that you should make x to be negative 1. And when you make x to be negative 1, you'll have 2 into negative 1 equals a into negative 1 plus 1, then plus b into negative 1 plus, negative 1. So if you look carefully, it will be negative 1 minus 1. Like this. And if you have a look, you will see that this term here will amount to 0. And all what you will end up having is negative 2 equals negative 2b, like this. And what you should be able to see is that your b will be equal to 1. So now that we have our b, we can now therefore go to the original expression and see that our 2x cubed divided by x squared minus 1 is actually 2x. Then the partial fraction form we have worked on already. We found a as 1, so it will be 1 over x minus 1. And then plus also we found the b as 1, so it will be 1 over x plus 1, like this. This is the answer for question number 8. So make sure that you understand how these functions which are improper work. Okay, so let's have a look at example number 9. And on example number 9, you should see right away that the degree of the numerator is 4, but the degree of the denominator is 2. So from here, you should be able to note that what we have here is an improper fraction. And as previously noted on problem number 4, once you have an improper fraction, you first need to do long division, of which that is what we are going to quickly do now before we start doing our partial fractions. So what we are dividing is our x to the power of 4 plus 3x, and this is getting divided by, let's put in the sign, this is getting divided by x squared minus 4x plus 4. So let's go ahead and divide. So x to the power of 4 divided by x squared, the answer will simply be x squared. So we take the x squared, should multiply what we have down there. And when it multiplies, we get x to the 4 minus 4x cubed, then plus 4x squared, like that. So we subtract the 2. What you will see is that the x to the 4 and the x to the 4 will cancel. And what we will have is 4x to the power of 3, and then minus 4x squared, and then plus the 3x that comes from above there. Then what we will now do is to take this and divide by it there. So long division, I need you to go and look at the first session, or the session which we posted on polynomials if you don't understand. So if you divide 4x cubed with x squared, what you should get is 4x. Then you take the 4x, you multiply by it there, and what you will see is that you will get 4x cubed, then minus 4, or 4 times 4, that will be 16, so minus 16x squared, and then plus 16x, like that. And if you look carefully, these will subtract, so the 4x cubed and the 4x cubed will cancel. Then we'll be left with 16 minus 4, which will give us 12x squared. And if you look carefully, we'll have negative 16 minus 3, and that will be minus 13. Okay, that is what we have. It's minus 13x. Just feel free to correct anything should I make a mistake. You just divide now 12x squared with that, and if you look carefully, what you get is just 12. And we now take the 12, we multiply by it, and we get 12x squared. If you look carefully, minus 12 by 4, so by 2 it would be 24, and then by another 2 that will be 48. And then plus 48, like this. Then when we take the difference here, you should be able to see that we will have 48 minus 13, and that will be 35x if you look carefully, minus 48. And what sits here becomes our remainder. And now all what you need to do is to go and complete this problem, and I'm going to leave it as homework. So essentially what is going on is what we had there, which is x to the 4 plus 3x divided by that, x squared minus 4x plus 4. The answer which we are getting is x squared plus 4x plus 12. And then plus our remainder, if you look carefully, becomes 35x minus 48, like this. And this will be divided by x squared minus 4x plus 4. So that there needs to be splitted into partial fractions. That is what you need to go and do. But on that, what I have as a tip is that you are going to have, if you look carefully, 35x minus 48 divided by x squared minus 4x plus 4. If you observe this carefully, you will see that the denominator you can factorize. And when you factorize it, you'll see that it's x minus 2, x minus 2. So essentially, it's x minus 2 squared. So which means you'll have 35x minus 48 divided by x minus 2 all squared. And if you look carefully, here you have a repeated factor. And you can go and look at the beginning of the session where you were supposed to be making notes of how we deal with this. But essentially how we are going to deal with it, it will be a divided by x minus 2 Because it is squared, so we'll have b divided by x minus 2 all squared. And now you need to go and find a and b as your homework. So let's go and have a look at example 10, which is the last one. Then we conclude this session. This one will be homework for you to go and figure out what is A and also what is B. Okay, so let's have a look at example 10, which is a very soft one. We'll end the session with nothing hard. And if you look at this, this will be a proper fraction. So for example number 10, it should be very easy for you to be able to deal with this because it's just a recap of what we did previously. So if you look at the denominator, we have linear factors. So when we split it into our partial fractions, it will be a over x plus 1 plus d divided by, plus b divided by x minus 3. And when you quickly multiply by the common denominator, you'll see that we'll get 7x minus 6, which will be equal to a into x minus 3 plus b into x plus 1. So you should get to a point where you are able to do many of these steps without writing a lot of them down, because time is what you are chasing whenever you are solving a problem. You are trying to save as much time as you can. So for a, by now, you should easily be able to see that we should make x negative 1, which means we'll have 7 times negative 1 minus 6, a into negative 1, negative 3, plus b into negative 1 plus 1. And there you go, that becomes 0. And if you look carefully, you'll have negative 7 minus 6, which will be negative 13. And then you will have negative 4a. If you look carefully, your a here should be equal to 13 divided by 4. And then we can now quickly go and have a look at how do we find b. So if you look at b on that expression which is above here, you should be able to see that you only need to set x is 3 to be able to find b, which means we'll have 7 times 3 minus 6, and that will be equal to a into 3 minus 3 plus b into 3 plus 1. If you look carefully, we'll end up having 3 times 7, which is as good as 21 minus 6, which is going to be equal to 15. And if you look carefully, we'll have 4b there, which means our b is 15 over 4. So we now have found our answer. If you look carefully, let's just create some space and conclude on this. If you look at our answer, so we are given 7x minus 6 divided by x plus 1 and x minus 3. What we found was that a is 13 over 4, so we have 13 over 4 divided by x plus 1 plus our b, we found 15 over 4 divided by x minus 3. So this brings us to the end of this session. I hope that you do understand, and with practice you will get better at these things. What is very important is what we wrote on page 1 of this session, not the first page but this page here. Very important, where you're looking at the compact form to the splitted form. So if you look at these and read them, you will be able to work out these problems easily. Okay, thanks for watching. Bye bye.